Hello, everyone, and welcome to our keynote live from Stuttgart. I would also like to extend this welcome to our virtual audience that are joining us today also with the LinkedIn live stream. This session will last approximately 45 minutes, and after that we will have a Q&A session for those of us that are here in this room in Stuttgart. We'll have the opportunity for Q&A. But also for the virtual audience, you will have the opportunity equally to post any comments or any questions that you have in the chat box, and we will be able to answer that after the event. So, to today's subject, we are considering how the power of AI will make robotics a powerful catalyst for change in the logistics sector and bring a new generation of logistics automation. This is actually a transformation of a sector that requires people to conduct very often repetitive and tedious tasks. And this transformation implies the creation of a new environment where robots can relieve people from this task and enhance new levels of productivity and flexibility. To introduce and explain how ABB is developing the tools and solutions to enable this revolution, I'm joined here today by Daniel Navarro, our Global Business Line Managing Director for Consumer Segments and Service Robotics, and by Jordi Artigas, who is our Global Innovation Manager. I hope you are looking forward to this session today as much as I do. And now, without any further ado, I would like to hand over to Daniel. Over to you. Thank you.
Thank you, Laura, and thank you everyone for joining us here today at LogiMAT in Stuttgart, and the ones who are virtually through live stream. I'm really happy to be here with all of you. And in order to explain how AI will help shaping a new era for logistics automation, we're going to ask and answer some few questions, simple questions. So let's start with this one. What do these two items have in common? Right? We see a car in the left, we see a parcel in the right. You would ask, wow, I think that really nothing, right? But one and the other has many parallelisms in the way that how the industry was transformed through automation and robotics, and how we see this is the starting point for logistics automation through robotics. Let's go a little bit deeper on the car, on the left side of the picture. Robotics and the car industry has been evolving together in a perfect symbiosis. For many years, robotics has been enabling mass production of cars, and also the development of this industry has pushed robotics to the level where we are today. One without the other would not have been working alone. Just to give an example, in the 70s, Ford, at the time was 14,500 employees, started to deploy the first 6-axis robots in their factories. Since then, ABB has been supporting companies like Ford and many others in automating this production in order to enable mass production. Why historically automation was linked to productivity, how to do more, how to do this faster, how to have higher quality, and this has been the trajectory of robotics. But now we see more and more, even more demand. Now we see a shift in the generation, looking more for sustainability, personalization, and this is why the technology is evolving to support higher simplicity, higher flexibility, making the things easier for the car industry. Today, we also see the mega trends. So shortage of labor, shortage of skills, aging of population, that is requiring even more automation in industries like automotive, for instance. But also, there are some applications in the auto industry, like welding and painting, that are already fully automated today. Just for example, the American Welding Society has long predicted the shortage of welders in US of around 400,000 welders in the next 2-3 years. That's really massive. And if we see the Industrial Federation of Robotics has just announced that there has been already 1 million robots deployed in the auto industry. That's really a milestone. The focus now is more on delivering higher flexibility, implementing more intelligent solutions to support the industry that is facing different challenges, like moving from combustion to electrical vehicles, for instance. But if we move then to the right for the parcel, it can be said that many of those challenges are also in logistics. Today, we see also shortage of labor. We see that the consumer is the king. I want to buy this, and I want my name on it, and I don't want this in 5 days. I want it tomorrow or even today. And this is putting a lot of pressure in the industry, in logistics. We see some leaked Amazon research warning the company that they will face problems in finding workers for their warehouses in US in 2-3 years' time. Or we see many other firms announcing that logistics will follow the similar path as automotive 40-50 years ago, with much higher automation. Amazon also says that a robot can pick 1,000 items per hour, which is much faster than what a worker can do, right? And we see also some companies like DHL Supply Chain that they already deployed 700 assisted item picking robots in their warehouses in US, in Europe, and in UK. So that's massive. But the next obvious question is, what is the potential to automate this, right? To extend with the automotive comparison, we can see that logistics is in the level that automotive was 40 years ago. There is some implementation of automation, but we are still in the starting point. According to Interact analysis, they mentioned that they are estimating 150,000 item picking robots in 2030. So, when we will reach 1 million? Probably 2040? That's a good question. But this is still obviously a strong potential to grow in this curve. That brings us to the third question. So why this does not happen still, right? Why there are 1 million robots in the industry, in the car industry, but so few in the logistics automation? And this is a vital question today, and is bringing on the shift on the technology, on the power of the AI and the machine learning that will shape a new era for logistics. The automation in the warehouses is facing different challenges. Let's take an example of this worker who she's able to identify which is the object that needs to pick. She's able to identify, okay, how I pick it, and has the dexterity to take it from the shelf and put it in a bin, right? Even in a structured way, she does not know what is the next item to be picked. But this is very simple for a human. It's even repetitive, sometimes even subconscious. But this brings a lot of challenge for the robot. How to be able to pick things that we don't know, that are not informed before, and how to have the dexterity and the ability to handle this situation. This brings a very complex equation. And that's why AI is the solution for that. I would like to introduce Jordi, who can explain us what are the developments for the AI into our item picker.
Thank you, Danny. Indeed, a very complex equation, straightforward for us humans, but really, really complex for a robot. But it's even more than that. So going back to the analogy with the car industry, how many parts does a car have? Somewhere between 20 and 30,000 parts. However, those parts, they are perfectly known. They're perfectly known, and we know perfectly how those parts need to be combined in order to create a car, to assemble a car. And once this is done, basically you copy and paste, right? In logistics, this is rather different. We have millions of items. And those items, They are never known in advance. And besides, they can change on a weekly basis, on a monthly basis. So that, of course, drastically changes what we have done in the past for automotive. And the answer is AI, of course, right? So let me give you a very simple example. This is a phone, and I think we all agree that this is a phone, right? However, a phone, there can be different models, right? Different number of cameras, different sizes, shapes, and so on. And but we all agree that this is a phone because we all have a model of what a telephone is, right? If we start deforming this item, at some point, some of us will start saying, hey, this is not a phone anymore. Some of us will say, okay, yeah, I think this is still a phone, right? That means that we have some sort of threshold up to which we agree that this is a phone, and from which some of us will say this is not a phone anymore. AI is basically reproducing this mechanism, right? To create models of reality. I remember very well my daughter, who is now 6. When she was just a few weeks, months old, she would grasp an object, a toy, and she would spend, minutes, half an hour, looking at that object. It's a beautiful scene. We've all seen that. She was creating a model of that particular item, just as we're creating models in logistics. So that's exactly what AI and logistics is about. So in this example, we're training a model for an item category, which we call a cup of coffee. But we know that logistics is not just about identifying or finding an object. It's about picking. It's about grasping. Therefore, grasping is equally important. And the same process can be identically applied for the grasping part. So when my daughter was, looking at that item, at some stage, she would drop that item. And my wife, she was, a little bit mad. Hey, stop doing that. But I kept thinking, hey, don't tell her that because she's building a model. She's training her convolutional neural network, recursive, multi-layer, right? So she was creating a model for grasping and a model for visuals. So where should I grasp this item from, right? So we can train that for a robot because there are more optimal ways of grasping this object. And this is exactly what we can do in AI. And once we have that, we have the model. And then things do not need to be exactly the same. That's the key point, because we have this threshold from which we identify that this is a cup of coffee, from which we determine what's the good grasping area. So what does that mean in logistics and item picking? And when we say item picking, actually, we're referring to any picking robots that we can find in logistics. Small parcel singulation for the parcel industry, sorter induction, for fashion and apparel, for instance, depalletizing, it's all about the same. The challenge is always the same. Unknown items and finding the right grasping points. In this example, I took fashion because fashion actually is one of the most challenging cases. It is even hard for human eyes to determine the segmentation. Where do those items begin and end, right? So, and where to grasp from. And here is the magic, where the magic comes. Thanks to this idea, these neural networks, we managed to train the system such that it can first find the grasping points, second, do the segmentation. And this order is actually important as well, because we're actually much more interested in finding grasping points than finding actually where the objects are. As long as we can pick, we're good. And if we can find the segmentation, even better. So what is our AI recipe for logistics? Very simple. Number one, we train for segmentation. Number two, we train for grasping. Then we apply the filter. The filter basically transforms an image, a picture that has been taken onto the bin, onto the tote, onto the pallet, and it outputs optimal grasping points. That's the whole idea about it. And now, handing back to Daniel to share some really exciting news.
Thank you, Jordi, for the explanation. Really like the example of your daughter, and it really make me think, I mean, how we all are learning continuously, no? So global market, as we discussed about the automotive, right? The global warehouse market is growing at a pace of more than 11% compound average rate based on global markets estimates. And as we mentioned, it's not only the growing, but it's also the increasing on complexity, right? With higher personalization, higher customization, with the consumer wanted to have the things now and not in 5 days' time, right? So all this is changing, and we're happy to announce that we launched yesterday our AI-enabled robotics item picker, which makes fulfillment faster and much more efficient. Robot has the ability, thanks to the AI, to learn, identify the object, where to grasp it, and the dexterity to move it and decide where to place it. This with a very high speed, up to 1,400 picks per hour, with a great efficiency, more than 99.5%. And this is a very great milestone that we achieved here today. The robot, the technology, does not require any human intervention, or even does not require the robot to know what is coming next. What are the attributes of the objects that it needs to pick? The AI will enable this technology to make it possible to identify the object, to identify the grasping point, and take it from there. Let me show you the video, and where I hope that you can see and understand this better. This is the video for the robotics item picker. So for those who are here, if you did not have the opportunity to visit us in our booth, I really encourage you to come and see. Our team there will be more than happy to explain much more details of what we explain here. But that's really amazing, and this is a breakthrough technology. But logistics is not only about item picking. We know that also the movement of goods, how they are transported, this is very relevant. And we are very happy also to announce the new technology that we are adding to our AMRs, which is called VSLAM. And for that, Jordi, I want you to explain this in a better way.
Thanks, Daniel. And the challenges in this case are actually very similar as to the previous ones. Unstructured environments, dynamic, things can change, and flexibility. We want flexibility, right? So that's what brings us to the introduction of a new technology, which is called Visual SLAM. Visual SLAM has been developed in cooperation with our partner company, 7 Sense. And what does SLAM mean? SLAM stands for Simultaneous Localization and Mapping. So what does that mean? Basically, if we allow me to go back to the previous example of my daughter, when she approximately turned 1, she was able to start walking, right? And I remember very well when she was trying to walk from the kitchen to the dining room. She used to look for features. The table is there, that is there, the wall is there, and she was using those references to localize and, compute the trajectory until the dining room. And it was just a walk of 3-4 meters, right? SLAM is essentially about the same. It's about finding features in order to triangulate and find with as much accuracy as possible where the AMR is located at this time. And at the same time, map the environment. Now, Visual SLAM basically is a breakthrough because we're using off-the-shelf cameras in order to build 3D maps. Thanks to AI, the system can identify relevant features in order to create the map, right? Once the map is created with those relevant features, then the system, the robot, the AMR knows what it is because it finds those references. But how to find those references? This is where we're using AI exactly, right? So this is a very powerful technology. We've been testing whole last year, proving that this completely outperforms the state of the art of SLAM, which is 2D SLAM based on LiDARs, and we're ready to introduce it in our new portfolio of AMRs. Besides that, Visual SLAM offers a new dimension of possibilities because Visual SLAM is about 3D, and 3D is obviously more than 2D. If we take a forklift, for instance, a forklift always requires a laser scanner on the top, plus some reflectors, some markers, some artificial landmarks in order to properly do this triangulation. With Visual SLAM, we can apply this technology for forklifts, but we can also apply it identically for goods-to-persons AMRs, because we're looking on the floor, to the front, to the back, to the ceiling, because it's 3D, right? Plus the fact that it's based on cameras, off-the-shelf cameras. You can really use cheap cameras if you want for Visual SLAM. So there are some real hardware cost benefits in Visual SLAM as well. But besides that, since we're bringing similar perception capabilities as those of humans onto the AMR, it means that we can do many other things, like semantics. So a human is not just an obstacle. A human is a human, and we can identify that it's a human because we are applying AI, right? We identify that it's a human, and we localize the human in the environment. You can apply that to pallets, to shelves, to whatever. And with that, you can bring a much higher level of intelligence onto the AMR with respect to the 2D SLAM classical solution based on LiDARs. Which are the key benefits of Visual SLAM? First of all, it's robust, it's more robust and flexible, and we're pretty certain when we say that, because we did very intensive endurance testing with our R&D team in Spain. We did all kind of perturbation on the sensors. We applied some smoke, we did some occlusion on the sensors, and the system was still able to localize. As long as there is one single camera that can find one feature, it's enough. It's easy to integrate and commission. Basically, we don't need any additional infrastructure like you would need in many other cases where you're using 2D SLAM. And it does the job. It really does the job. It's robust, it's accurate, it's actually more accurate than many 2D SLAM commercial solutions in the market. So we're convinced that this is the way to go. We are really breaking the ice here, introducing a very new technology, very powerful, and this is the beginning of a new journey in mobile robots. Let me show you how this looks like in reality.
Thank you, Jordi, for explanation. Really amazing, the technology. Thanks to our partners, 7sense, who works with us in this. This new technology is transforming how AMRs are performing. This new AI-enabled navigation technology allow the AMR to take more intelligent decisions in a changing environment, in an unstructured environment. As we discussed, it reduced commissioning time up to 20%. It does not require any additional infrastructure. It's faster to deploy, and it's really useful without any calibration or less calibration than the regular AMRs. This innovation, combined with our strategic acquisition in 2021 of ASTI Mobile Robotics, makes ABB as the only company who can offer in their portfolio robots, AMRs, and machine automation as one-stop shop. And it opens new possibilities for the AMRs in new environments where the previous technology was not allowing us to work or interact. And it really helps logistics operators to look further, to look for different alternatives and solutions. With all these innovations, if we put them together, these are mapping the new way of logistics. As it happened in the auto industry 40, 50 years ago, we see now the starting point of integrating robotics into the warehouses and logistics industry. With all this, we start to see the transformation, and if we put together these new technologies with some of the other portfolio that we have, we can see a tremendous potential and how this is transforming the setup of the logistics, the setup of the warehouses. Let me show you one example, last example, and this is an automated flexible cross-docking solution that we put together in this animation. Roughly speaking, this cross-docking means resorting of goods that are being received from one carrier to another one. In this example, we see at the inbound dock area that the pallets are transported to the high-density pallet storage with our autonomous stagger AMR using VSLAM. The motion between AMRs are fully orchestrated by our fleet management system, and the flow of goods is managed by our warehouse control system. There are different options to build customer orders. First one is with a single case with flow rack based on the ABB depalletizing technology. Once the goods are placed on the buffering rack, the palletizer can fully build the customer pallet. Once the pallet is finished, the first available AMR will bring the pallet to the outbound area. The second scenario is a single case with pushback rack. After the palletizing, the ABB Flex Buffer will be used for ordering consolidation. It offers an efficient solution for sequencing, buffering, and sorting. And most important, is fully modular, so therefore scalable. The last scenario is a full layer palletizer with these rainbow pallets, which could be probably the most leanest and fastest way to build the customer pallets. And finally, when the order pallets are ready for shipment, the AMRs will bring them to the outbound trucks, if necessary, through wrapping and labeling. So wow, this is really a big piece of automation. This is a new way of structuring and automating warehouse, in this case, this cross-docking example, as we put it here. So today, we have been discussing, first, we talk about auto and how this really evolved during the last 50 years, but why logistics was still not there. And we learned that this is because the technology was not ready for that. We show today a pair of cases with our AI-enabled robotic item picker or our VSLAM technology applied now in the AMRs, who will bring more opportunities to further automate, to start higher penetration of robotics and AMRs in the logistics and warehouse environment. these two new robots or these new two solutions is a part of the portfolio that we will continue evolving as we speak. Let's take this opportunity to make a difference here, to automate even further into the logistics and to transform logistics into new levels to support with higher productivity, flexibility, and simplicity. So with this is what I wanted to show. I pass to Laura for the final words.
Thank you, Danny. Thank you, Daniel. Thank you, Jordi, for your inspiring and super interesting presentations today. I hope you all enjoy it. This concludes our live stream for today. I would like to thank you, the audience who joined us today virtually. If you would like to discover more about our innovative solutions that we presented today here, and also about our comprehensive portfolio for logistics, I invite you to visit our website, where you can learn all about our great portfolio that we have. I would like to thank you again. Goodbye, and enjoy you the rest of the day. Thank you. All right, so now we are here, closed room. It means that it's time for you to ask any questions that you might have. We have about 15 minutes. If we need to stay longer, stay longer. It's the opportunity. We don't have always here Jordi and Daniel, so let's take this opportunity. And to break a bit the ice, I will start by asking you a question, Jordi. After this masterclass on AI, I'm actually interested to know, how do you train AI for item picking? Can you please explain that in a easy to understand?
No problem, no problem. Actually, it's very simple. So maybe I should have mentioned that earlier, but actually, until today, until recently, this whole AI stuff, training, labeling, and so on, was really reserved to AI gurus, right? With our new item picker, our new offering, we really want to empower anyone to do the training themselves. Actually, we can do both. We can train the system ourselves because we know very well how to do it, of course. But we developed a user interface that allows really anyone to do the training. And the training essentially means to do some labeling. So it's really like a game. Identify, with some landmarks, which are the nice grasping points that you would like to have. It takes about 1 hour to train for 100 items. This is more or less the ratio that we have. To label. Once you're done, you basically press one button. The training will happen in the cloud, so that takes a few hours. Depending on the number of images and the complexity, it can take 4, 5, 6 hours. It's always less than 1 day, definitely. And then you get the train model, the train network that you can immediately apply on your item picker. So training today with our item picker is really like a kid's game.
So even I can do it.
Absolutely.
All right, thanks a lot, Jordi. Now it's time for you. Don't be shy. I would like to ask our colleague Jürgen, who has the microphone. Yeah, so I think we have a question there. Yeah?
I'm flying. Sorry. No, thank you for the impressive presentation. Great technology coming up. I'm very curious how you will manage the orchestration between your fleet of AMRs and the robots. Is it kind of a software package what comes on top, or how do you want to orchestrate that?
Yeah, and at the moment...
No, you take it.
It's a great question, and it's a great question, and it's really on the top of our agenda, because we really believe that orchestration is the way to create new value. On one hand, we have the AMRs. On the other hand, we have the simulation robots, the palletizing robots, but we need to do a proper orchestration to that. So today, we have our in-house solution, which is called FMS Advanced, Fleet Management System Advanced, which does the full orchestration of AMRs, and it can already integrate some, it can do some triggering of robots. And next to that, we also have another software tool, which is called Material Flow Control, MFC, which allows a higher level of orchestration to put more robots into the same system. So at the moment, we have two solutions. And depending on the specific use case, it is more appropriate to do it based on pure fleet management or using the MFC, Material Flow Controller.
Thank you. Yeah, here.
I have a question about your training. When you train the 3D map, if you have the racking, do you have the empty racking so you can classify the objects as racking, and the SKUs or the articles you put on later so the map knows that this is things that moves and this is things that stays?
You're talking about Visual Slam now?
Yeah.
Yeah. So it's basically training on semantics. So normally the training itself, so the AI happens in the 2D plane. So we want to identify a human or a shelf, and that is normally done in 2D because today AI is still mostly based on 2D. And then next to that, we want to localize. Once we know that this is a human or this is a shelf, the next stage is where is it exactly with respect to the map. So we're combining basically classical segmentation based on 2D plus this localization of the specific item.
Good. So we have one here on the other side.
Hello, Knüpfer von Logistik heute. I have a question. You have explained some scenarios with fully automated systems. And do you need people to work there in the future?
That's a very good question. I mean, it depends obviously on the level of automation and specifically on the level of the applications that you are applying. There are some areas where you can have a dark warehouse, right, with no people there. But there are some others where you still need persons doing some more activities that the robots cannot perform. So it will depend, and this is something that I'm sure that it will be evolving. We see already some areas where you have dark kitchens, for instance, with for food service, where there's no intervention there. But there are many others, still in the automotive, for instance, where it's extremely automated. There are still some areas where it requires human intervention.
Good. More questions about what you saw, about other logistic solutions? It's your opportunity.
Then I'll take one more question. What about loading? Knapsack theory and to have a good filling rate?
Can you elaborate a little bit more?
Yeah, when you load packages or parcels,
okay,
it's stochastic. You don't choose which size comes first. They come in a stochastic manner, but you want to have a good fill rate in your transport, so you try to eliminate air, so that there you have this knapsack theory, how to fill it in a good way. That's a good automation task to do. Have you thought about that?
For building pallets, for instance.
Transport or loose loaded or bed loaded or whatever you want to transport it.
So basically here there are different software tools that can be used in order to build the pallet Tetris in an optimal way. So it is not in our scope today yet. But I mean, we've tested those tools. Normally those tools, they will give you the most optimal pallet configuration. Normally it will require some buffering in between. And at the moment, so this is, if someone asks to do this kind of pallet optimization, that would be our answer. One of the key areas that we're also exploring is the mixed case palletizing, right? And one of the key challenges in mixed case palletizing is precisely how to optimize the pallet configuration as well to make it stable, right? So yeah, stay tuned because this is gonna come in the future, quite near actually.
Yeah. More questions? We still have some time, huh? So don't be shy. No? Well, I think then if there are no more questions, this concludes our presentation and Q&A for today. I would like to thank you again for joining us. Thank you, Jordi. Thank you, Daniel. And if you want to discover more and see actually the item picker that you saw in the video in action, you can actually go to our booth. If you have not been there, it's located in Hall 6, number G07. You will see the big ABB red logo. So I'm sure you will find it easily. Our colleagues will be there to tell you all about our solutions for logistics. And I wish you a good remaining of the day and next days here in Stuttgart in LogiMAT. I hope you enjoy it. And thank you again and goodbye.
Thank you.